Hello friends, continuing with the topic of Ohm's law, today we come to part 3 of it, and it is the Ohm's law itself. Statement: physical conditions like temperature and pressure of the conductor remaining constant. Potential difference developed across a conductor is directly proportional to electric current flowing through it. I repeat, physical conditions like temperature and pressure of the conductor remaining constant, potential difference developed across a conductor is directly proportional to the electric current flowing through it. Mathematical expression: if I be the electric current flowing through the conductor and V be the potential difference developed across it, then V is proportional to I, or V is equal to Ri, where R is constant of proportionality known as electrical resistance of the conductor. Therefore, mathematically, Ohm's law is expressed as V is equal to IR. If we plot VI graph is a straight line. Okay. Assignment 3.1 continued. Question number 11. The storage battery of a car has an EMF of 12 volt. If the internal resistance of the battery is 0.4 ohm, what is maximum current that can be drawn from its battery? Electrical resistance of a conductor. First, definition: the property of a circuit by virtue of which it opposes the flow of electric current through it. I repeat, the property of a circuit by virtue of which it opposes the flow of electric current through it. Or we can define it in another way: electrical resistance is the obstruction faced by the electrons in going from one end of the conductor to the other end under the action of applied electric field. This obstruction is represented by hills and valleys inside the conductor because of zigzag path followed by an electron. Now look at the diagram. Here the hills and valleys are there and the electron follows zigzag path. So we represent the resistance by zigzag path. Now cause of electric resistance, why it is due to. So this obstruction is because of collisions of electrons with atoms and ions of the lattice of the conductor. Due to collisions, the kinetic energy of electrons is transferred to atoms and ions in the lattice, and they start vibrating about their mean position. More is the amplitude of vibration, more is the obstruction. More will be the number of collisions. More will be resistance of the conductor. More will be temperature of the conductor. Lesser will be the relaxation time. So mathematically we can express electrical resistance directly proportional to number of collisions, directly proportional to amplitude of lattice vibration, directly proportional to temperature of the conductor. And relaxation time, tau, is inversely proportional to amplitude of lattice vibration. This opposition to flow of electrons, that is electric current, is called as resistance of the conductor. I repeat, this opposition to flow of electrons, that is electric current, is called as electrical resistance of the conductor. 2. Mathematical expression. Mathematically, electrical resistance is defined as the ratio of potential difference developed across the conductor to the electric current flowing through the conductor. I repeat, electrical resistance is defined as the ratio of potential difference developed across the conductor to the electric current flowing through the conductor. Let V be the potential difference developed across the conductor when I be the current flowing through it, and if R be the electrical resistance of the conductor, then R is equal to V by I. Now 3. Alternative definition of electrical resistance. Let us see. Slope of VI graph is also defined as electrical resistance of the conductor. Now look at the graph, VI graph. Here the slope is R is equal to dV by di. More the slope, more is the resistance. Lesser the slope, lesser will be the resistance of the conductor. Now SI unit are ohms. Now definition of ohm. Since we know that R is equal to V by I, and when I is 1 ampere, V is 1 volt, then R is equal to 1 ohm. Thus, resistance of a conductor is said to be 1 ohm when 1 ampere of current flowing through it develops 1 volt of potential difference across the conductor. I repeat, resistance of the conductor is said to be 1 ohm when 1 ampere of current flowing through it develops 1 volt of potential difference across the conductor. This is how we define ohm, the unit of electrical resistance. Now circuit symbol. Circuit symbol is as shown. It is zigzag path. Now assignment 3.1 continued. Question number 12. The VI graphs of two conductors P and Q are as shown. The questions are: A. Which of the two possess more resistance and why? B. Which of the two possess more temperature and why? Question number 13. The VI graph of two conductors at different temperatures T1 and T2 are drawn, which are as shown in the diagram. A. Which of the two temperature is more and why? B. Which of the two has more resistance and why? Now conductance. Qualitative definition of conductance. The property of a circuit by virtue of which a circuit easily allows electric current to flow through it. I repeat, the property of a circuit by virtue of which a circuit easily allows electric current to flow through it, or the easiness with which an electric current flow through conductor is defined as conductance. Quantitative definition. Reciprocal of electrical resistance of the conductor is defined as conductance. I repeat, reciprocal of electrical resistance of the conductor is defined as conductance and is denoted by G. So mathematically we can write G is equal to 1 by R, but R is equal to V by I, therefore G is equal to 1 divided by V by I, or it is equal to I by V, or finally we write G is equal to I by V. Thus the ratio of electric current flowing through the conductor and potential difference applied across the conductor is defined as the conductance of the conductor. I repeat, the ratio of electric current flowing through the conductor and potential difference applied across the conductor is also defined as the conductance of the conductor. SI unit, ampere per volt, or mho, reverse letters of ohm, MHO. Now alternative statement of Ohm's law. Since G is I by V, therefore I is equal to GV, or I is proportional to V. Thus Ohm's law can be stated as physical conditions like temperature and pressure remaining constant, current flowing through the conductor is directly proportional to the potential difference applied across it. IV graph. It is a straight line as shown in diagram. The alternative definition of conductance. The slope of IV graph of a conductor is also defined as the conductance of the conductor. I repeat, the slope of IV graph of a conductor is also defined as the conductance of the conductor. So mathematically expressed as G is equal to dI by dV. More is the slope of IV graph, more is the conductance, and lesser the slope, lesser is the conductance. For example, Gx is more than Gy because x has more slope than y. Therefore, Gx is more than Gy. Conductance of conductor X is more than conductance of conductor Y. Or resistance of conductor Y is more than the resistance of conductor X. Question number 14. The IV graph of two conductors P and Q are as shown. Which of the two possess more conductance and why? B. Which of the two possess more temperature and why? Question number 15. The IV graph of two conductors at different temperatures T1 and T2 are drawn, which are as shown. A. Which of the two temperatures is more and why? B. Which of the two has more resistance and why? Now, failure of Ohm's law. Ohm's law is valid only for low magnitudes of electric current flowing through a conductor, but fails at higher magnitudes of electric current flowing through a conductor. Reason being, at higher magnitudes of current, number of collisions between electrons and atoms and ions of lattice of the conductor increase, resulting into increase in temperature of the conductor. Thus, temperature of the conductor no longer remains constant, which is the required condition for validity of Ohm's law. Hence, Ohm's law fails at higher magnitudes. Now look into two diagrams. The first one is this diagram where VI graph is a straight line up to some extent. When current increases beyond this limit, the straight line is no longer there, but the curve, it is curved line, which shows that the Ohm's law is no longer valid beyond this situation. Here in the second graph, it is IV graph, where you can see that law is obeyed up to this point, and beyond this the IV graph is no longer a straight line, but it is a curved line. So this shows that the Ohm's law at higher magnitudes of current fails. Question number 16. The IV characteristic of a resistor are observed to deviate from a straight line for higher values of current as shown below. Question is why? Now, materials that follow Ohm's law. Metals or conductors follow Ohm's law and are called as ohmic materials. For example, platinum, gold, silver, copper, aluminium, and iron, etc. Now, VI graphs of ohmic materials is a straight line. VI graph of a ohmic material is a straight line. Now, materials that do not follow Ohm's law. Number 1, semiconductors do not follow Ohm's law and are called as non-ohmic materials. For example, carbon, germanium, silicon, stannous, and palladium. Number 2, insulators also do not follow Ohm's law. And VI graph of non-ohmic materials is as shown. Question number 17. Name two ohmic and two non-ohmic materials and draw their VI graphs. Question number 18. Identify the materials which do not obey Ohm's law. Copper, silver, silicon, aluminium, germanium, carbon and iron. Thank you so much. Next time we'll take up part 4 of this topic, factors affecting resistance of a conductor and resistivity. Okay. Till then, goodbye.